Hey everyone, and welcome. Today, we're going to do a deep dive into one of the most powerful tools in any programmer's toolkit, the while loop in Java. If you've ever wanted to make your code do all the heavy lifting for you, save you a ton of time and effort, you are in exactly the right place. Let's jump right in. So here's the game plan. First, we'll talk about why loops are such a game changer in the first place. Then, we'll get to know the while loop, understand its basic setup, and learn the secrets to keeping it under control. After that, we're going to put on our detective hats and trace exactly how it runs. And finally, we'll level up and unlock some serious power with nested loops.
Okay, so let's start at the very beginning, with a problem that every single programmer runs into: repetition.
I mean, think about it. You need to do the exact same thing multiple times. What's the first thing that comes to mind? It's probably not the most efficient way to do it.
You could just copy and paste, right? I mean, look at this. It works, sure, but wow, is it tedious? And it's super easy to make a mistake. Imagine if you had to do this 1,000 times. No way. That's just not going to work. There has to be a better way.
And that better, smarter way is, of course, using loops. Loops are a fundamental part of programming, designed for one specific reason: to handle repetitive tasks for you, elegantly and efficiently.
So, let's pull back the curtain on our first secret weapon against all that repetition, the while loop.
So what is it really? A while loop is actually pretty simple. It's just a rule that tells the computer, hey, while this one specific condition is true, I want you to keep running this chunk of code. The second that condition becomes false, the loop just stops. That's it.
And here's what it looks like. Think of it like a gatekeeper. The word while is the gatekeeper himself. The condition inside the parentheses, that's the secret password. And all the code inside the curly braces, that's the awesome party inside. As long as you give the right password, meaning the condition is true, the gatekeeper lets you into the party, again and again.
This brings up a really critical question, and it's a trap a lot of beginners fall into. What happens if we give the loop a password that's always correct?
Uh-oh. You get the dreaded infinite loop. If you literally tell Java, while true, you've basically told it to run forever. It'll just keep printing hi on and on and on, eating up all your computer's memory and probably crashing your whole program. We definitely need a way to control this.
So how do we tame this powerful beast?
Well, it all comes down to 3 essential keys. You need these 3 things to keep your loops from running wild.
Just remember these 3 steps. It's like a recipe. First, you initialize a counter variable before the loop even starts. Second, you use that variable in your condition. That's the password. And third, and this is the part people always forget, you have to update that variable inside the loop. That update is the magic ingredient that eventually makes the condition false so the loop can end. This little piece of code is the perfect example of our 3 keys in action. See? We start by initializing I to 1. Then, our while loop checks the condition, is I less than or equal to 4? Since 1 is, we go inside, print our message, and then, the most important part, we update I with I++. Now I is 2, and the loop gets ready to check the condition all over again.
So we've seen the code, but to really truly understand it, you have to learn to think like the computer. So let's trace the execution of our loop step by step.
All right, let's break this down. First time through, I is 1. Is the condition I less than or equal to 4 true? Yep. So we print hi 1, and then I becomes 2. Next round, I is 2. Still true? We print hi 2, I becomes 3. We keep doing this all the way through iteration 4. Now I is 4. Is 4 less than or equal to 4? It sure is. So we print hi 4, and then I becomes 5. But here's the magic moment. On the next check, I is now 5. Is 5 less than or equal to 4? Nope. The condition is finally false, and just like that, the loop stops. We're done.
Okay, so based on what we just saw, here's a quick question for you. Once the program has totally finished with that loop, what's the final value stored in the variable I?
The answer is 5. And it's so important to understand why. The final value of I is the one that actually broke the loop. It's the first value that made the condition false. The computer checked it, saw it was false, and moved on, leaving I with the value of 5.
Okay, so we've seen how to repeat one action, but what if you need to repeat a repetition? Now this is where things get really fun. It's time to level up and check out the powerful idea of nested loops.
You know, the best way to get this is with an analogy. Think of an outer loop as counting the days of the week. Now, for each single day, let's say Monday, an inner loop has to run completely, counting all 24 hours. Only after the hours loop is totally done does the day loop finally move on to Tuesday, where the whole hours loop starts all over again.
Let's build this from the ground up. Here's our outer loop. It's all set to run twice. On its first run, it's going to print high 1. Then, right here in the middle of its code, we're going to drop in our inner loop. After that inner loop does its thing, the outer loop will continue, print high 2, and then kick off that inner loop all over again.
And here's what that looks like all put together. Right inside our first loop, the one controlled by I, we've plopped a brand new, completely separate while loop. And notice it has its own 3 keys, its own counter J, its own condition, and its own update. So for every single time the outer loop runs, this inner loop is going to run its full course, printing hello 3 times.
And this is the result you get. The outer loop runs once, printing high 1, then the inner loop takes over completely and prints hello 3 times. Only after it's done does the outer loop get to take its next turn, printing high 2, which then triggers the inner loop to run completely, again.
So, what are the big things to take away from all this? First, while loops are your best friend for automating repetitive stuff. Second, you have to remember the 3 golden rules: initialize, condition, and update. Third, if you forget that update, you're headed straight for an infinite loop, so be careful. And finally, nesting loops unlocks a whole new world of possibilities, letting you create some really complex, layered patterns.
And that leaves us with a final thought to chew on. You now have the power to control repetition in layers. So think bigger than just printing text. What kind of cool grids, tables, or complex patterns could you start to create with this simple but incredibly powerful concept?